A rectangle whose length and width are 10 and 6 respectively is shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Which line could the rectangle be rotated around? So let's go through the options here, just because we can definitely solve this really quickly if we have a bit of number sense, but I feel like that may not necessarily be the way for everyone. So I'm going to go through and maybe perhaps going through it visually, you can then be able to tell what the options are, or which of the options is going to be the correct one. So I'm going to go through option 1 here. If we were to rotate this rectangle along the long side, right, so long side length of 10 here, if I do that for option 1, right, what will end up happening is I'm going to end up with a cylinder that looks like this. And actually, the length of, or the height of the cylinder is going to be 10. And the radius is going to be, so the radius is going to be 6. So if I take a look at this right here, the volume of the cylinder would be pi times 6 squared times 10. And if I do that, I'll end up with 36 pi times 10, right? Because 6 squared is 36. And the 36 times 10, that would be 360 pi. So that wouldn't be, that's way too large. Okay. Let's take a look at another one. Option 2. So option 2 says to rotate it along the short side. If I were to do that, I'll end up with a cylinder that's going to appear flatter, right? Where the height is going to be 6 and the radius is going to be 10. So here radius is going to be 10 and the height is going to be 6. And let's see what happens here. V is equal to pi r squared times 6. And as it turns out, this flatter cylinder actually ends up being way bigger. And if you were to pause for a moment and to maybe try and wonder, like, well, which dimension actually causes the volume to jump more? Is it the height or the radius? You should be able to suspect that actually the radius has a bigger influence as to how much change or how much influence it has on volume, because we're taking the dimension of the radius and we're squaring it. So clearly that's going to have a much bigger impact. So here the volume is 600 pi. Let's take a look at option 3. If I rotate it along the vertical line of symmetry, right? Along the vertical line of symmetry. So if I take this rectangle and I rotate this along the vertical line of symmetry, I'm going to end up with this. So I end up with a cylinder. This time the radius is 5 and the height is 6. This is 6 and the radius is 5. So what's the volume then? So the volume here is pi times 5 squared times 6. And 5 squared, that's 25, right? So that's 25 pi times 6. And 6 times 25, well, that's just 150. So actually, option 3 is the correct choice here. Let's just go through option 4 just to, while we're at it. The horizontal line of symmetry, if we were to do that. So if I take the cylinder and this time I rotate it around the horizontal line of symmetry, I'll end up with a cylinder that looks like this. Whoops. Again, horizontal line of symmetry. So the radius will end up being 3, and the height will end up being 10. So the volume here in this case will be pi times 3 squared times h, which is 10. So here in this case, I'll end up with 90 pi. Because 3 squared is 9 times 10, I'll get 90 pi. So yes, option 3 is the correct solution then.